So the next part is to conduct the polarity test. So first we will find the rated voltage winding of the transformer. Okay, find the rated voltage of the winding terminals. Okay, between terminals 3 and 4, what is the rated value we have to find, and then calculate the uh, value 50% of the rated value and record the value in the template. Let us see. So the rated value between 3 and 4 would be 208 volts, because this third, the middle 208 volts refers to this winding. So half of it would be 104 volts that would be recording in the template. So that is 208 volts are recorded here, and that is the 50% of the rated voltage, 104 volts there. So the next step is to program meter A. So in metering window, activate meter 3, so we need meter 3 also, I guess, and then identify meter A. This A is generally for old DIs, we use this A, and for new DIs we use M5. So we are not using new DI, we'll just ignore that one. So we'll go to this one and I'll close this. I will also erase this one. So I will activate E3. This is meter A. If I click here, right click in meter settings, so this is voltage. If you set it here, and it will add two voltages. What are the two voltages we have to add? E2 and E3 we have to add. E2 and E3, E2 plus E3 we have to add, and just press OK. So that will give you the sum of these two voltages there. Okay, so let us see how it goes. What is the next step? So now we'll wire the circuit. So the plus sign, it says this is the plus sign. Generally in the meters, if you see circuit diagram, on top of the terminal would be plus terminal there, but especially for this one is the plus is the here at the bottom. A lot of students, they make mistakes when they do the circuits. That's why that note is given there. If you do not follow that note, what will happen? There is a possibility of getting a wrong value. So we'll set up the circuit now. I'll just focus the computer to the field, and then we'll try to record the try to wire the circuit. So this is the setup there. So we will, I think, follow again from number 4. Number 4 will be, let me take this one. It's number 4. From number 4, it's going to I1. So number 4, it's going to I1. This is the incoming terminal, and the outgoing, from the outgoing terminal it's going to number 3. The outgoing terminal is going to number 3 of the winding. So number 3 of the winding here. From the 4 it goes to N. So white color I will be using. So white color, number 4, it's going to N. So that is the main circuit. This power supply, this is the high potential terminal. It's going to I1 to sense the current, and it's going to the transformer, and it's coming back to the power supply. So, and then we will be connecting E1 there between 3 and 4. E1 between 3, this red and white color. red and white color. So we'll take these two. So white. So since I'm using color code blindly, I can connect to that white color there, and that is the lower potential terminal, that is the higher potential terminal, the red one. I can connect here. So this voltmeter is connected across the winding there. In the secondary side we from number one yellow wire. So one yellow wire should be going to, okay, 1 and 5 they are shorted first. So let me short these 1 and 5. That means we are trying to connect these two windings in series basically. So when we connect this one in series, this would be the point, so that would be starting point and it's going there, and it will be ending point kind of thing. So now E2 should be connected between 1 and 2. E2, so yellow and black. E2. So 1, E2. So E2 positive, and that one black should be going to negative. Okay, it can fit there. And then E3 between 5 and 6, so that is blue and yellow. So 6 is blue. Should be going to plus. So that is the catch here. That should be positive there. And then between 5 and negative there. That's correct. So we connect. So if you observe this one, no two colors are mixing here. Nothing colors. No colors are mixing here. And we used I1, E2, E3 we are using there, and the power supply is there, so this should be fine. So let me go to the instructions, see what is saying there. So the next instruction says checking the power before turning on. So I already checked it, and will turning on the power 2.5 is powering up. On the power supply, turn on the main switch and slowly vary the voltage control knob to apply a voltage of 104 volts, and meter E1 should read 104. So if we go to this meter E1, so meter E1, this one should be showing 104 there. So I'll make sure it is 0 position. I'll turn on this and apply voltage slowly, and I will be applying here. If you observe, maybe I don't know whether you are able to see it or not, it should be 104. Okay, 90, 100 is now close. Oh, that's fast. So it's showing around 104.4 there. So I'll just leave it, or I can adjust a little bit. So it's showing 104.21. It's oscillating. So that must be the. So I will record that one and then shut down the. That's it, I guess. Snipping tools. Record it is the voltage turn off. Okay, so I'll just turn off once I record it. So basically I captured the data here. So you can notice that we applied 104 volts here, and the other side the voltage is each winding was showing 60 and 60 volts. but if you see the sum of the voltages, it's showing 0. So that is the catch about this experiment. So why it is showing 0, you need to think about. So this is it's you, you cannot these are the voltages, they are the phasors, so you cannot just algebraically add it. You have to add vectorially. So the point is that in the polarity test, so the when two windings are connected in series or in parallel, so depending upon the polarity of each winding, the voltages, it would either it would add or subtract depending upon the phase orientation. That way you have to think of in the answering when you answer the question there. Okay, so to avoid lengthy videos, so I will not give too much explanation here. So the next step is to modify this circuit. So this is the circuit we have to modify. So I think this circuit is basically same for both the things. So primary should be same, only the secondary side here 1 and 5 were shorted, 1 and 5 are connected here together, and now here 1 and 6 will be short. That means we are reversing the this winding basically, and then taking the measurements. So we'll see what is happening. So I'll just modify the circuit according to this one, and so I will just remove the wires here, 1 and 6, that will be connecting to 6 there, and for this blue wire should be connected to 5, that's correct, and then this wire E3, so E3 negative is connected here. So basically I just switch this one, and then I will turn on this one and see what is happening. So I will turn on the power now and apply again 104 volts. Very close. So 104 points, that's good, very good. So apply that much, and then we can see closely. So we can see closely this one. So that is 104 volts. Again 60 it's showing here, but in this second case here, now it's showing the double the voltage. Like double the means the sum of the voltage, it's showing there here. Before it was showing around 0 voltage, here it is showing double two times of this voltage, or sum of these two voltages. So that is what the same windings, just by changing the connections there, so it gives different results. Either they can aid each other, or subtract each other, or oppose each other, kind of thing. So that's what I will record this one and meet you in the next step. So I recorded this data here. You can see that 120, 104, 60, 60. That's what before we watched it. And what is the next? So we recorded and reduce the voltage to 0, and I will turn off, disconnect the wires. I will disconnect the wires soon. Just a quick note, observation is mentioned here. Just a quick observation. If you think your attitude as a polarity, you may have synergy with same attitude person, or nullify with opposite attitude person. So if you have similar attitude person, you get synergy. If you have opposing attitude persons, you nullify the efforts, and you'll get basically you'll get troubles. So that's why choose wisely your association. That is the reason the association is very important. Okay, so we will see you in the next. I think it's next test is the open circuit test. We'll see you in the next video.